Chapter 5, Fluid Mechanics. Section 5.1, Density. So we talked about density previously in Chapter 1, but the density of an object is just a measure of its compactness. How much stuff divided by how much space. So when we calculate the density of something, we use its mass divided by its volume. Here you have listed just some common densities of particular materials. Notice heavier metals like platinum and gold are very dense. Uranium, lead, those are very dense. Lead is what we use to block X-rays, so it should be very dense. Aluminum is not very dense. And ice is somewhere around 919 kilograms per meter cubed. That value will be important in just a moment. If we look at the liquids, mercury is by far the most dense liquid at about 13,000 kilograms per meter cubed. But then you have seawater, which is a bit more dense than water at 4 degrees Celsius. And then we have things like gasoline and dry air, which has a low density, but still a non-zero density. The air still has mass. One thing I want to point out is that the density of ice is less than the density of water. So when we talk about fluids, it's sometimes helpful to talk about what we call the weight density. And the weight density is just the weight divided by its volume rather than the mass. It's just accounting for the acceleration due to gravity. And one really important thing to remember about density is that if you have a solid that's less dense than a liquid, it will float in that liquid. So for example, ice is less dense than water, and so ice floats in water. Iron is less dense than mercury. So if you tossed a chunk of iron into a vat of liquid mercury, the iron would float in the mercury. Water, however, is the only substance where its solid floats in its liquid. Every other substance, the solid is more dense, and so it sinks to the bottom. The liquid is less dense, so it floats to the top. With water, the solid is less dense, so it floats. And so oceans freeze over from the top down rather than from the bottom up. And if it were the opposite way around, then the oceans would never unfreeze. They'd remain frozen all the time.